Hello, everybody. I'm just going to run through some of these phase change diagram problems. I'd like you to see how really this is just about reading a graph. There's nothing to memorize here or anything like that. So let's just run through a couple of these together right now. Number one, so what is the state of water at 2 atmospheres and 50 degrees Celsius? So if you look at this diagram, 2 atmospheres is somewhere around here. Okay, so about 2 atmospheres right there. And 50 degrees Celsius is somewhere around here, 50 degrees Celsius. So that puts our point right there. So the state is liquid. All right, move on. What phase change will occur if the temperature is lowered from 80 degrees Celsius? So here, let's do this in green. 80 degrees Celsius at 1 atmosphere of pressure and reduce the temperature to like -5. Okay, we're going to go in this direction as we're cooling. We're staying at 1 atmosphere of pressure, so what we're going to see at this place right here that I'm kind of highlighting right there is we're going to see freezing. So we're going to go from liquid to solid. Okay, moving on. You have ice at -10 degrees Celsius. Here, I'm going to erase this real quick just to clean it up. Okay, we have ice at -10 degrees Celsius. All right, at 1 atmosphere. Okay, so there we are at about -10 at 1 atmosphere. What would you do in order to cause the ice to sublime? What that means is you're going from a solid to a gas directly. All right, so in other words, we're going to go from this pressure down to that pressure, okay? Or past that pressure, in fact, okay? So we would have to pass from the solid state into the gas state, and that would be sublimation. So the answer to the question is we would reduce the reduce the pressure to like at least 6/1000ths of an atmosphere or so. All right. All right, so on the next page here, I'm going to fill this in as solid and liquid and gas. All phase diagrams are going to go in that order. So solid and liquid and gas, just as you see it. What is the normal freezing point of this substance? All right, normal means at 1 atmosphere. So what is the normal freezing point of this substance? Going from solid to liquid, that looks like we're at about 100 degrees Celsius. Okay, this is clearly not water, right? What is the normal boiling point? Well, normal means we're at 1 atmosphere, so roughly we are at about, whatever that is, let's say 460 or something, okay? Again, this is just about reading the graph, nothing more than that. What is the normal melting point? Okay, now freezing and melting, they both happen at the same temperature. It just depends on which direction you're going. So the melting point is the same as the freezing point. It's 100 degrees Celsius. If I had a quantity of this substance at a pressure of 1.25, let's do this in a different color. So a pressure of 1.25 atmospheres, okay. Temperature is at 300, so somewhere around there, okay. And we lower the pressure to 0.25 atmospheres. That's going to take us down to about there or so, okay. what phase change will we see? We're going to go from liquid to gas, so that would be boiling. Okay. All right. At what temperature do the gas and liquid phases become indistinguishable from each other? This is what we did not talk about in class. That was actually the critical point, which I just put in red there just now. Let's not worry about it. Let's move on. If I had a quantity of the substance at 0.75 atmospheres, all right, let's do this in a different color. Let's go with blue. All right, 0.75 atmospheres right there, and a temperature of minus 100. That puts me there. What phase change would occur if I increase the temperature to 600? Okay, staying at the same pressure, we're going to go to 600 degrees. All right, if we're really careful here, it looks like we've got two phase changes. We're going to see melting here. I'm just going to write it in there. Melting there, and we're going to see boiling here. Boiling. Okay. All right. That's assuming that I was careful with my drawing, but I think that is true for that question. Okay. All right, good. Let's try this next one. Okay. All right. This first question is asking about the critical temperature. I'm not that interested in critical temperature, but I'm going to give it to you anyway. I'm putting a blue dot right where that critical point is. The temperature looks like it's at about 760 Kelvin or so. No, Celsius. 760 Celsius. Whatever you think that is, you can make your own decision. All right. If you were to have a bottle containing this compound in your closet, what phase would it most likely be in? Okay, your closet is going to be at 1 atmosphere of pressure. 1 atmosphere of pressure looks like here. I'm going to say that is 1.0 because this is 10. This is a bad graph. This is 10. This is 20. Let's just call this 1 atmosphere of pressure. And what else did it say? We're in a closet, 1 atmosphere of pressure and at room temperature. So that puts us at about what temperature is that? That's going to be about 20 degrees Celsius. So we're really about right there, okay? So that whatever that stuff is, it's going to be a gas. Okay. At what temperature and pressure will all 3 phases coexist? That is the triple point. Looks to me like we're at about 40 atmospheres and 350 Celsius. 40 atmospheres, 350 Celsius. Again, this is all about just reading the graph. If I have a bottle of compound X at a pressure of 45 atmospheres and 100 degrees Celsius, what will happen if I raise the temperature to 400? So we're going to stay at 45 atmospheres, and we're just raising the temperature. 45 atmospheres puts me about there on my pressure graph. And we're going from 100 to 400. Okay, 100 to 400. Okay, we're going to go through there. We're going from solid to liquid, so that's melting. Okay? Hope you can see that that's what's going to happen on that graph. Why can't compound X be boiled at a temperature of 200 degrees Celsius? 200 degrees Celsius. The reason is because this substance will not exist in the liquid phase at that temperature. I'm just going to say that, and I'm not going to write that down. But you can see that we're not going to have a liquid phase, and in order for something to boil, you got to have a liquid. Okay, if I wanted to, could I drink compound X? No, because remember, at 1 atmosphere of pressure and at about room temperature, it's a gas. You don't drink gases. And in order for it to be liquid, you would have to be at least at about 460 degrees Celsius and at about 43 atmospheres. So no, you cannot drink this. You would be dead, and a dead person can't drink this. All right, I think that's enough of this, and hope that was helpful to you. I will put this in the student resource folder.